This section is going to deal with exponential functions. Let's first define what an exponential function is. An exponential function is a function where a number is raised to a variable. So for example, f of x is equal to a to the x is an exponential function, where a would be a number. A has to be greater than 0 and cannot equal 1. And a is called our base. So let's graph an exponential function, and then we're going to look at some properties of exponential functions and then how to graph transformations. So graphing f of x is equal to 2 to the x. This is an exponential function because it's a 2 raised to a variable. And let's graph it by making a table just so we can kind of get used to what this looks like. We're going to insert the values of -2, -1, 0, 1, and 2. Starting with -2. Well, if I raise 2 to the -2nd, well, negative exponents means to flip this. So that's 1 over 2 squared, which is 1/4. So the first point I have is -2 and 1/4. Let's make it right about there. Next, negative first. So 2 to the negative first. Again, negative exponent, I need to get rid of that. So 1 over 2 to the first, which is just a half. So at -1, I'm at a half. 2 to the 0 power. Well, 2 to the 0 power is 1, so the point 0, 1. 2 to the first power is 2, so at 1, my y value is 2. Finally, 2 to the second power is 4, so at 2, I'm at 4, which is right here. Let's connect those dots. Notice that I did not cross the x-axis. Let's think about why I did not cross the x-axis. Is there any number that I can plug into 2 to the x that's going to get it to equal 0? Is this possible? No, negative numbers are just going to flip me like they did up here and get me smaller numbers. So if I want to plug in 2 to the -100, well, let's grab a calculator and see what that would give me. So just an example here. So 2 to the -100. So 2, and I'm going to raise it to, in parentheses, 100. That gives me a very, very, very small number. Well, what about 2 to the 1000, -1000? That gives me another very, very, very small number, but never does it give me 0, and never does it give me anything negative. So my line here, no matter what I do, I'm never going to cross the x-axis, and I'm never going to be negative. Well, when we approach something but never cross it, we get what's known as that asymptote. So exponential functions have a horizontal asymptote. Let's fill in this chart over here about the domain, range, x and y intercept, and asymptote of 2 to the x. Well, let's take a look at it. What is a domain? Well, domain from a picture, remember we can see leftmost point is an arrow, rightmost point is an arrow, so my domain would be -infinity to +infinity. What about my range? Well, the lowest point, I'm trying to get to 0 on my y-axis, but I'm never going to get there. Since I'm never going to get there, I'd have parentheses 0. Highest point is an arrow, so comma, infinity. X-intercept. Do I ever cross the x-axis? No. The x-axis, I have a horizontal asymptote there, so I would write none. I don't have an x-intercept. What about a y-intercept? Well, here's my y-axis. Do I cross the y-axis? I do at that point. What's that point? Well, that point is 0, 1. And we've already talked about the asymptote. The asymptote for this function is this green asymptote, and that's the equation of the line y equals 0. Remember, horizontal asymptotes are always y equals a number, and this one is y equals 0. Let's look at graphing a different exponential function, and then we're going to look at what happens in general for exponential functions. We're looking at f of x equals 1/2 to the x. Again, this is a number raised to a variable, which makes it an exponential function. Let's plug in our normal values of -2, -1, 0, 1, and 2. If I take 1/2 and I raise it to the negative second, I need to get rid of my negative exponent, so I take the reciprocal of 1/2, which is 2, to the positive second, and this gives me 4. 1/2 to the negative first. Again, get rid of the negative exponent, so 2 to the first, and I'm looking at 2. Let's put those 2 points on before we forget. Here's negative 2, 1, 2, 3, 4. And then we have negative 1, 2, negative 1, 2. Now 1/2 to the 0 power. 1/2 to the 0 is 1, so 0, 1 again. 1/2 to the first power. 1/2 to the first power is just going to be a half. So at 1 I'm at a half. And finally 1/2 to the second power. 1/2 to the second power is 1/2 times 1/2, which is 1/4. If I connect those points, again, it looks like I want to be on this x-axis, but I'm never going to get there because there's nothing that I can raise a half to that's going to make me negative or 0. So I am again going to have a horizontal asymptote here at the x-axis, which is y equals 0. So let's find the domain, range, x and y intercept of this picture. Domain again, leftmost point is an arrow, rightmost point is an arrow, so it's negative infinity to positive infinity. Range, again, lowest point, I really want to be 0, but I can't be 0, so I would say parentheses 0. Highest point is an arrow, infinity. X-intercept, I'm never going to cross that x-axis. I have a horizontal asymptote there, so I would write none. And my y-intercept, well, here's where I intersect the y-axis, and again, that's the point 0, 1. And we know our horizontal asymptote is y equals 0. So these two are examples of what exponential functions look like. Let's talk about some in general properties of exponential functions. In general, if we have a function that's exponential, so a to the x, without any transformations, so that means no vertical, horizontal shifts, or reflections, its domain's always going to be all real numbers. So if it's just in the format of a to the x, its domain's going to be all real numbers. Its range is going to be 0 to infinity. It's always going to have a y-intercept at 0, 1, just like we saw, and it will not have an x-intercept. Its horizontal asymptote will always be y equals 0. And then these are just nice to know. If a is bigger than 1, then the function is increasing. So let's go back to our pictures here. Well, here the number 2, which is our base or our a, is bigger than 1. Notice that as we move to the right, the function's going up. That's called an increasing function. The second one says if a is between 0 and 1, so if it's a number between 0 and 1, then the function is decreasing. Well, let's look at our 1/2 to the x. 1/2 to the x, 1/2 is a number between 0 and 1, so as we move to the right here, notice that our function's going down. That's called the decreasing function. And finally, and this is really important because we're going to be using it to graph, all exponential functions have, in that basic form, or just as a to the x, have 2 anchor points. And we're going to be transforming these 2 anchor points. So it's really important that we memorize them. It's 0, 1, that y-intercept, and 1a. 0, 1, and 1a. Let's go back and look at the 2 that we graphed before to notice those anchor points. Notice we got the point 0, 1, that's right here, our y-intercept, and then 1a, 1a. Because if you look here, what is a? Well, a is my 2, because it's a to the x, so this is 2 to the x, and then there's the point 1, 2. Did that happen with 1/2 to the x? Let's check. Yep, we still had the point 0, 1. There's the point 0, 1, and then 1a. Well, a here is a half, and there we go, 1a. We did get 1a. It's right there. Right, the very next video is going to talk about the natural exponent function and then actually transforming these functions.